Okay, good evening, everyone. Today we continue our discussion on some application of linear programming. So it's the way that I teach linear programming to you, you exposed to some type of problems. So next, if I give you some assignment or homeworks, or even in the final exam, you should be able to do that because you already saw something very similar. From last week, we couldn't go over assignment problem. So let me read it. There are four jobs and 8 employees. You have to assign one job to 2 workers. One more issue is their worker EF and G cannot be assigned to any job. But one of the 3 can. So the constraint would be that among EF and G, either one or none of them can be assigned to a job. So for job assignment is a cost problem, so we try to minimize the cost. So let me see who's not muted. Yeah, give you a couple of minutes, and also I try to figure out who's not muted. So, okay, so we have 4 jobs, 8 workers. Each job should be done by 2 workers. These are the associated costs. For example, if worker A you assign to job number 2, you should pay $6. For E, if you assign to work 4, you should pay $16. Also, one worker cannot be assigned to 2 jobs. Each job must have 2 workers, and the last constraint, E, F, and G cannot work together, but you can assign one of them. Still, you need to somehow some creativity. So let's say for E, F, and G, and let's assume these are just integer numbers. They are not like decimals. So if I said E plus F plus G, S will equal 1. If I just add this constant. So do you think these 3 could be assigned to one work or one job? So they are integer values and positive, so they are more than 0. So if I assign worker E with the value of 1, F and G would be 0. So it just means you cannot assign these 2. If you make what F1, these 2 would be 0. So you just assign one of them. All of them could be 0 too, right? Because 0 is less than or equal 1, summation of 0 plus 0 plus. So what happens, it just this constraint, E plus F plus G, less or equal 1. You cannot assign these 3 together, but one of them could be assigned. Any questions about this constraint? I know it might be, you might say how you understand you should add this concept. This is the act of creativity, and for the who solved it. I didn't solve it, I just saw the solution. But the first one who solved this problem ended up being very creative to find the one constraint that could translate that sentence.
So is the example related to the question? Like
Yes.
that question. So there are basically 4 jobs and 8 employees, right? So
Uh-huh.
2 employees will be doing one task. Is that what it means?
Yes.
So wouldn't in this case 2 of them have to be one person?
No, if two of them get one, it's not less or equal one.
Okay.
When I put less or equal one means at most one of them could be one. Let's open the Excel file. But again, no worries. If such a problem looks very hard, actually they are very easy, but it just needs a click in your mind how to set up the constraint. So it's not a math problem that needs integral or so much of calculation. It just needs some creativity click in your brain. Otherwise, such a problem, I think this problem next, if in a few days would be super easy for you. But if it doesn't click in your brain, it might take like days and you cannot solve it because it comes out of complete creativity, not any math formula. So this blue cells means if I assign a worker to a job, they could be 0 or 1. So for example, and look at the last button, is assignment cap. So it just means worker A just could assign to one work. You cannot assign one guy to 2 different jobs or work. This 0 is just summation of all of those blue cells. And you then compare this summation with 1. If it's, you should be sure that that summation won't be more than 1. If it's more than 1, it just means you assign one worker to 2 different jobs. Also, you have a row summation here. It just takes care of each jobs. For example, job 1, you sum up all of the workers that assigned to it, and you want to check it should be equal to. Because based on your policy, each job should be assigned to 2 workers. So we'll just open the Excel file and just click on each of them. So it just makes a little more sense. So we have a row constraint and a column constraint. So row constraint takes care of jobs, and you want to be sure each job assigned to 2 workers. Column constraint takes care of your worker. You don't want to assign them to more than 1 job. Also, we have for each work job 1 to 4, we should take care of EFG constraint. For example, I have a column of EFG not working together. Just click on each of them. It just some of the blue cells under worker E, F, and G. Let me just click in. Even the last one, just take care of assignment of if E, F, G on job number 4. So later on for this column, I can assign EF, E plus F plus G less than equal 1 to be sure just at most one of them is assigned to that job. I give you a couple of minutes for you to just play the formula in your Excel sheet. Also, you can, I think you can easily understand what does total cost sell means. It's just assignment times the cost. So I give you a couple of minutes to go through the Excel file. Then I go to the solver part. So any question about the setup? Yeah, if you have a question, no worries, just ask. I know it might be a little challenging, but it's the first time you see such a problem, but it's the way that we try to learn operation research. So click on solver. So look at the first constraint, E20 to L20 is the assignment row. I put equal E21 to L21, just means each worker should assign to just one work. You cannot assign more than one. The next constraint, M14 to M17, equal N14 to N17. It just means each job should be assigned to 2 workers. So again, it may not be the most efficient way of formulating. So instead of saying like L20 up to, so E20 to L20 equal E21 to L21, you can just say equal 1. For the next line, you can say just equal 2. You don't have to do my formulation. Maybe you can find a better formulation. Also, the last constraint is just for EFG. We want to have a policy of excluding them to work together. So we want either none of them or just one of them at most assigned to a work. It's like, it might be similar to projects. Maybe some of you say, yeah, I have problem with him or her. I don't want to be in a one group for project. So maybe you can just make a operation research problem and try to avoid them to be in one group. Okay, press on solve. I don't go to sensitivity because I think last two or three sessions I talked about that. So press OK, and total cost just 50. Okay, so now open the multi-step transportation problem. So is it one step harder than the previous transportation problems that we worked with? So we have we have 4 production points, 2 warehouses, and 3 demand points or customer points. So you have costs associated to each link from origin to warehouse to destination. And basically your constraint is on how much you can produce and how much you should consume. Also, we have a warehouse capacity too. So let me read the problem. Oranges are produced at Orlando, Phoenix, Austin, and San Francisco. The production at each place is given. There are 2 warehouses, Denver and Springfield. The capacity of each warehouse is 400 crates. Cost of sending 1 crate of oranges from each source to destination is given. Oranges are finally required at Kansas City, Omaha, and Chicago. Requirements and costs from warehouses are given. So if you read the problem, we also have 400 as the constraint of each warehouse. Part 1, objective is to ship oranges from warehouses and then to a store with minimum cost. Part 2, assume there's so in part 2 it's more realistic. So assume that there's a loss of 10% oranges in each transfer. In other words, 90% of the oranges reach from source to destination in every transfer. Source to warehouse and warehouse to destination. It just means you lose 10% from your source to warehouse and second 10% from warehouse to destination. Okay, I give you a couple of minutes to read through the problem to see what can you understand. Then I go to the solution. Well, it's pretty much similar to previous transportation problem. You might remember, I think you found the problem, right? So it was not feasible. Yeah. So it's similar to that. So you have a constraint on the resource or origin. You have a constraint on destination. Here, we have 1 more on warehouse. It's just a little harder than that problem. I give you a really good bonus because this typo happened last semester and nobody found it. So last semester I gave them that typo and nobody figured out. But you're the only, you found it this semester. That was really good.
You made it.
No. Last semester it was just a typo. So it was a typo also in one of the column of Excel, but nobody understood. Everybody accepted. But you're the only one who found the problem. Yes, sometimes happen. I remember when I was undergrad, it was a textbook and I studied hard and I couldn't solve the problem. I couldn't understand the solution. And I was thinking it's my problem. I tried hours and hours and hours. Then I showed it to my instructor. He said, there's a typo here. So sometimes when you buy the first edition of books, there's tons of typos. Usually in the second edition, they add 1 extra page of typos. But usually in the first edition, sometimes you may stuck in some places because of some stupid typos. So I solved this problem 2 ways. One way is needs more creativity if you want to do through Excel. Another one through Lingo. For your final exam, you can submit over Lingo. It doesn't need that much of creativity. So let's look at the problem. So obviously, I have it seems you can divide it into independent problem or two separate problems. One problem or two sections, let's say not to say two problems. You can have a table to take care of everything from origin to warehouse, another table to take care of everything from warehouse to destinations. Okay, having said that, open the Excel file, go to the first page. I know it might look a little weird, but is how I did it. So I divided in two sections. S1 to S4 just means source. To W1 to W2, warehouses. So these blue cells are my decision variables. And I took care of two types of constraints for this one. One is my warehouse, which has capacity of 400. And it gets, for example, warehouse one gets its materials or products from S1, S2, S3, and S4. Here, I put the summation of whole column. It just means whatever gets to W1, sum them up here, there, and I check if it should be less or equal to 400. Same for W2. You might get products from S1, S2, S3, S4. This is one section, so I take care of constraint of W1 to W1 and W2. The second one, also I need to take care of my production capacity or supply capacity. So S1 is my origin one or supply one, can send to W1 and W2. If you click on this 0, it just sum up whatever I sent from S1 to W1 and W2. Whatever I sent from my first supply to warehouse 1 and warehouse 2, I sum them up. Later, I want to check it should be less than 240 because if you look at the problem, the capacity of S1, which is Orlando, is 240. I cannot send more than 240. So this is another constraint. Let's just close this one. Second table takes care of whatever you send from warehouse to destinations. Still, I have, look at the first row. Whatever it's just, and click on 0. It just sum of whatever you send from warehouse 1 to destination 1, destination or demand point of 2, and destination of 3. Later, I check whatever went out of my warehouse should be less than 400 because it's the capacity of my warehouse. Same for warehouse 2. I send this summation or the formula that you click on it, take care of whatever you send from second warehouse to destination 1, 2, and 3. Also for each destination, if you which are my columns, if you click on zeros, so it just takes care of whatever went to destination 1. Some products goes from warehouse 1 and some goes from warehouse 2. Same for second destination and third destination. So basically, I had a complex problem. One way, just take care of the first part and second part separately. So if it's after my destination, I have secondary destination, I ask you to solve the problem. Maybe you need to add one extra table for secondary destination. For example, you may not consume everything Kansas, Omaha, or Chicago. Maybe you need to send something outside. So you need to add one more table. Any questions so far? So you have mask, I cannot understand completely, but I think some of you got disappointed from this problem. But no worries, I mean, it's your first time we see such a problem, and it might be kind of challenging. So let's look at the data solver. Let's check, let's first check the constraint. I31 to K31. I31 to, okay, the first constraint taking care of my demand point, it just says I31 to K31 is the summation of the products I deliver to demand points of 1, 2, 3. It should be more than my demand. You can consider as equal, but my policy is just provide at least what is needed in the demand point. So the policy matters. Maybe you would say, no, I want exactly, that should be exactly equal to demand points. Second line, I24 to J24. So I24, J24 should be less than equal I25, J25. It's just saying that, so whatever you send to the warehouse should be less than 400. Third row, K20 to K23 should be less than equal L20 to L23. It just says whatever you send out as supply should be less than your supply capacity. You cannot send more than that. And the last line, I24 to J24 should be less than equal, sorry, should be exactly equal to L29 and L30. It just says whatever comes to warehouse, it should goes out. You cannot send, so whatever comes in, comes out. So input should equal out. Any question about the constraints? So again, before solving, so let's check these yellow cells. So the first one is the cost of sending from supply points multiplied by decision variable of sending. So it just gives you how much is cost from origin to the warehouse. Second yellow cell is just talking about the cost from sending from warehouse to the supply to the demand point. So you multiply the decision variable, so warehouse to demand points times the cost. And the last one, just sum of both of the costs. So to warehouse and from warehouse. If you go to the solver, I'm trying to minimize T18, which is the total cost. Press solve, and this is the answer. So, any questions? So before getting to Lingo, let's try to solve it another way. So you might remember for transportation problem, we also had this setup. So in the rows, you have each link, and so the column F is the cost of each link, and the blue column is just the decision variable related to that link. But our constraints are on each point. For example, Oregon to Denver and Oregon to Springfield. So this is outward links. So the coefficient under Oregon is -1 because it just means you send something out of Oregon. Or sorry, Orlando. So for Philadelphia, it's just negative. Look at Denver and Springfield. So you have some +1 and -1. It just means for whatever comes to your warehouse, because it's an inward link, we put the coefficient of 1. For any links that related to the products that you send out of the warehouse, you put -1. So for Chicago, Omaha, and Kansas City, they just have inward links. So the coefficient for all of those is 1. For the first 4, because you just send out, the coefficients are negative. If you click on row 18, it just basically the coefficient times the decision variable. And we want to check later if they should be basically less than the absolute value of -240. So basically, this 0 here just means how much you send out of Orlando. And we need to take care of a constraint saying that we cannot send more than 240. Or for Philadelphia, if you click on this 0, just means decision variable times the direction or coefficient. And we check that, sorry, it's Phoenix, should be less than 240. You cannot send more. Same for Kansas City, Omaha, and Chicago. So that row, the value is 0 because the decision variable are 0 here. But you just care that at the end, decision variable times the direction or coefficient should be more than the demand. Oh, sorry. Okay. So which is more than, at least more than or equal to 100. Here for Denver and Springfield, I put 0. It's just taking care of everything comes in should go out. Because you have some links here. We don't want to put anything in Denver or Springfield. Every link that brings in should bring out. Should bring out. Or also look at the last 2. I'm taking care of the inward links because I know the capacity of warehouse is at most 400. So if you click on this 0 here, it's just talking about okay, so it's for outward. So outward links, and same for here. So the way that here instead of checking, because we already have a constraint, everything in, everything out. So instead of focusing on saying that whatever comes in should be less than equal 400, we said everything that goes out should be less than equal 400. These are equivalent because we already have a constraint saying that everything in, everything out. So you can either put a constraint on saying everything that comes in should be at most 400 is equal to say that everything that goes out should be less or equal 400 because we know that these 2 are equivalent. So let me show on board here. So for Denver, we have 4 interval links and 3 outward. we already have a constraint saying that this summation of these two should be equal. So these two zeros are taking care of that. We just said this zero just means summation of whatever comes in and out, and we said it should be equal to zero because the last row is zero. So we also have another constraint saying that the capacity of this warehouse is at most 400. You can either settle on the left side or the right side. They're exactly the same because we already forced them to be equal. But maybe it's more intuitive if you put in the left side. But I put here, I just consider the right side. So basically, in these two ways, I recommend the first one because first one is more intuitive. Second one is needs a lot more creativity, but at the end, you want to just formulate some association between your constraint and decision variables. Any questions about the formulation? I give you 1 or 2 minutes to think about that, then I just go to the Lingo problem. Okay, so Excel is not too difficult, but it needs some creativity to formulate it. So, but no worries in your exam. I won't expect that you should be creative in your final exam. So if I ask you to do Excel, you show exactly something similar to that. So I don't expect you to be creative in the final exam. So no worries. But these types of problems, these are actually different subjects in operation research. So like people study like, let's say 1 chapter on transportation problem. But for you, we just look at some applications, but again, no worries. But also let's try through Lingo. So through Lingo, you don't need to be creative. It's much more straightforward. So having said that, just Google download Lingo. And you get to the Lingo website, that's same. Click on it. So either 19 or 18, both of them are fine. So let's click on 19. You just put your information. Just Google Lingo, download Lingo. So let me you just Google this. Lingo. Yeah, I already installed it, but for you, just click next, next, next. That should. No, you just go use the student version. So I give you like a few minutes to download Lingo and then have it ready. Yeah, demo version. So demo version is not bad, but it's for education. You cannot make too many, a very large problem. So for example, at most you can have 150 constraints, 300 variables. There's still a lot of, you can make a really large problems, but not for basically business or industry cases. Yeah, just use the demo version. So you, demo version. When you start to ask you license, you just put the demo version. Huh? It doesn't open. That's Okay, so yeah. So similar to other software, just go to File, Open, and I already gave you multi-stage transportation, LG4. Press Open, and you can bring it here. So you see some notations, but no worries. S stands for source, W stands for warehouse, D stands for destination. So for example, when I say S1, W1, it just means whatever you send from supply point of 1 or source of 1 to warehouse 1. So let me show it on the problem. S1 is Orlando. W1 is Denver. Look at 3. So the cost associated to that link is 3, right? So basically, again, look at your lingo. S1, W1, it just means the decision variable for sending from your source 1 to warehouse 1. But I put the coefficient of 3 because whatever I sent from that link has cost of 3. So let's say if I send 10 crates, the cost is for each one crate is 1. So 3 times 10 crates, I should pay $30 if I use if I send something 10 crates from S1 to W1 or from Orlando to Denver. So any question why here I have 3 times S1 W1? If it doesn't make sense, just let me know. But again, no worries. If you have questions right now, that's totally fine because it's the first time you see such a thing. Yeah. Okay. Okay, so for Mac users, let me show a comment. Okay, I send you text, just copy and paste the text. So maybe I have somewhere, let's see. Okay, for Mac users, I send you this text, just open a file and just paste this text into your basically system. So let me go over model week 12. So multi-step.txt. Just open it and copy and paste on a new file over your Lingo. So anyway, does the coefficients of objective function make sense? Because my objective function is just minimizing the overall cost. So I should, how my cost is affected, my cost is affected by my decision variable. So each decisions that you make in terms of transportation has associated cost. So it's the reason I have those coefficients like 3, 4, 1. People over Zoom, if you have questions about objective functions, just let me know. Okay, let's look at supply constraints. By the way, look at the exclamation mark. When you put exclamation mark, you just make it a comment. The green line that you see there is just a comment, so it won't run. So can anyone interpret the first line? 1 times S1W1 plus 1 times S1W2 should be less or equal to 240. What does it mean? Yeah, exactly. So it just means S1 to W1 means Orlando to Denver. S1W2 means Orlando to Springfield. These are just, first I'm just saying whatever you send out of the source one should be less than equal to 140 because this is the capacity of Orlando. Same for Phoenix. Whatever you send from Phoenix to Denver, Phoenix to Springfield, the summation should be less than equal to 140, which just happened in the next one. And same for the last two supply points or our sources. Okay, let's look at the next couple of lines. Can anyone interpret the second line for me? S1W2 plus S2W2, S3 times W, S3W2 plus S4W2, less or equal 400. What does it mean? Yes, you're right. Exactly. So that the common part is W2 in them. So it just comes from S1, S2, S3, S4. Since the capacity of warehouse is less or equal to 400, you cannot send more than that. So this is the constraint for warehouse. I think the next two lines makes more sense. Now, it just, let me read the first one. S1W1 plus S2W1, S3W1, S4W1 equal W1D1, W1D2, and W1D3. What does it mean? Yes, exactly. So it just means whatever comes to the warehouse one should be equal whatever goes out of this. So in equal out. Yes, delivery point, demand point, or destination. So right side is just saying that whatever goes from first warehouse to demand or destination points, D1, D2, D3. Left side is just saying whatever comes to W1 is either from S1, S2, S3, S4. So we don't put left, we won't leave anything in warehouse. Everything comes in, should go out. And same for the next line. So before going to the last type of constraint, so just see for each decision variable, you make a variable here. So S1W1 is not S1 times the W1. It just means it's just a two sides of your link. So each link is a decision variable. So we put an associated variable here. So let's look at the last two constraints. Let me read the second one. W1D2 plus W2D2. Summation of them should be more than 300. More or equal than 300. What does it mean? Yes. Yes, very right. So if you look at here, so Omaha is my second demand or delivery points or destination. You can name it as you want. So whatever comes from warehouse 1, which is Denver, plus Springfield, which is warehouse 2, should be more than my demand. I want to fulfill my demand on Omaha or in Omaha. Again, based on your policy, you might sometimes put exactly equal, but we want to at least provide that demand. So based on your idea, do you think between Lingo and Excel, which one looks easier for you to formulate? None of them? I believe if you, let's say next class, we do some more in Lingo. So in Lingo doesn't need any creativity. You just basically, you know that you have some constraint. Where's my mouse? You have some constraint in your destination. So in origin, warehouse, destination. So you just, it's like how you write in a piece of paper. Almost you just type it here. Yeah. So there's a solve button. You just click on it. So it also gives you some sensitive analysis like a slack, surplus, reduce cost, final values. I'm pretty sure if you see some problems in Lingo, it looks much easier because in Excel, you should be kind of creative, like make how to connect those tables. Maybe at the beginning, Excel looks easy, but I'm pretty sure after a while, Lingo looks much easier for you. Yeah, I give you 1 or 2 minutes, then I go to the second problem. And second problem is your next assignment that you should do it in Lingo. So, but keep in mind, when you type in Lingo, let's follow exactly my format. For example, if it's mean, put mean equals something. So it's how you tell Lingo this is a minimization problem. And after each line, you should put a semicolon. You can use my code, just basically maybe you change some coefficients, but that's it. I mean, just keep in mind, usually people forget to put semicolon. Sometimes they forget to put mean, max, or mean equals something. Just if you don't forget that. And also I put a tutorial of Lingo on Moodle. You don't have to read it for your assignments, but just keep in mind, if you want to know more about Lingo, I put a tutorial on Moodle. Okay, let's look at your assignment part. Assuming there is a loss of 10% oranges in each transfer. It just means each transfer means from source to warehouse and then from warehouse to destination. Assume there is a loss of 10% oranges in each transfer, and actually you can help each other. So if you help each other, I don't consider it cheating. So you can help each other over even Telegram. That's totally fine. Okay, assume there is a loss of 10% oranges in each transfer. In other words, 90% of oranges each from source to destination, every transfer. Source to warehouse and from warehouse to destination. So considering there's a loss of 10% each movement, solve the problem. So it's still a minimization problem. We want to minimize the cost, but this time, for example, whatever you send from Orlando, Phoenix, Austin, and San Francisco to Denver and Springfield, maybe you should send 10% more because you lose 10% during transportation, or maybe near 20% because after the warehouse, you lose 10 more percent. Yep. So I give you a few minutes, then I go to solution. On the chart. Oh, chat. So Amina, I put a text document on Moodle. So go to Moodle, multi-step txt, open the text file, and just copy and paste the codes into your Lingo. Oh, okay. Okay, yeah. Thank you very much. I totally, I read it in another way. So, Amina, I help you, one of your friend, but let's see. I think one of you run Zoom right now, or Aditi, you run Zoom?
No, I'm on.
Oh no. So on, sorry. Yeah, ours. Yeah. I just let me see. Could you share your screen and tell your friends that how to solve the security issue? I'm gonna send something. So I mean, yeah, I mean, please ask over Telegram. I think in the class is a little challenging, but the fix is pretty easy. If it takes over Telegram. Okay. So okay, let's look at the solution. This time, I put the extra table coefficient of 0.9 because of 10% loss. But you need to smart in some way. I mean, first of all, for supply constraint, you don't have that coefficient because supply is just at the origin, which you don't have the loss at that time. So you see that I for 200, 240, 170, 180, I put those formula here because for supply constraint, I don't have, basically, I don't have the loss yet. But when it gets to the warehouse and goes out of the warehouse, at that point, I already have a 10% loss. So it's the reason, if you click on it, so sorry, here, this formula is just whatever goes into warehouse. So cell H29 to 33, these are basically the amount of products that get to warehouse one. Instead of summing up on blue cells, I sum up this yellow cell, because this yellow cell just means those blue cells times 0.9. So basically, I'm just, these formulas here, it's just talking about whatever comes into my warehouse is whatever I send out, but times 0.9. And same for the Denver. So whatever I decide about, I send from supply to the warehouses times 0.9. This bottom table is just talking about amount of products comes into my warehouses. How I formulate it, it's just my decision variables times 0.9. And after 0.9, I can understand what actually get to my warehouse. I have something similar for the destinations. So look at the destination, similar to the previous one. For finding what gets to some certain demand or destination points, it just whatever I send out of warehouse times 0.9 gives me this yellow cells. So it's just saying what actually would be delivered on those destination or demand points. So what are my constraints for this? Is basically one is the supply constraint. So I cannot send more than what can I produce. I have another constraint. Whatever goes after loss or after the 10% loss shouldn't be more than 400. Another one, whatever comes in goes out. That's still valid because I don't have any loss in the warehouse. The last one, whatever comes to demand points should be at least equal to my demand. At least or even more than that. So I give you 1 or 2 minutes to look at this coefficient and constraint of loss. See if you guys have some questions. But this is your assignment. So I put in the solution Excel file. You need to submit an equivalent Lingo. So you need to look at the formulation Lingo, see when should you put those 0.9%. And the good thing, when you solve it, you have the solution. So you can check your Lingo solution. They should be same. Huh? You can use Lingo for even your final exam. Next assignment. Just send me the text. Text. Yeah, I need to run your file. So if you're a Mac user, just copy and paste in a text document and send it to me. So. Okay, we have almost run out of time. So let me go to the solver part. So the objective function is still the same. So basically, decision variable times the cost coefficient. These are my, by changing variable stuff, it just means by changing those decision variables. Just see this comma here. Since I have 2 blue cells, which are my decision variables, after each blue cell, I have a comma. It just means I have decision variable separate part of the Excel. The first constraint, H33, I33, H33, I33 should be less than H34, I34. It just means whatever comes after the 10% loss shouldn't be more than 400. This is my basically warehouse constraint. The second one, H33, I33, H33, I33 should be equal Q17, Q18. Q17, Q18. Whatever comes in should goes out. So H33, I33 is whatever comes after 10% loss. Q17, Q18 is whatever goes out of my warehouse. These two should be equal. Next one, J16 to J19. J16, J19 should be less than equal K16, K19. So K. So let's see, K16, K19. Which actually, this one is also very intuitive. And last one, N31, P31. N31, P31 greater than equal N32, P32. So whatever gets to demand point should be more than my demand. I want to provide that demand. So let's click solve. Okay, this solution to 946. Let's compare with the previous solution. So before loss, the objective function, the value, final value is 2340, but with loss, you should ship more because you lose some. So you should pay 2946.54 as your transportation cost. There is no time, I think we ran out of time for second formulation, but I think if you look at the formulation, it's similar to this one. You just need to take care of where should you put the coefficient. So for you put the coefficient when you send from origin to the warehouse, and also for the part that you send from warehouse to the destinations. You can add that constraint too, but here I just relaxed it. But yes, better to just solve an integer because it doesn't make sense to send like half a crate. Yeah, you're very right. So, but for your assignment, that's okay. You don't have to consider integer constraint, but just formulate this in Lingo, and this is your next assignment. So either your Mac users or Windows users, just send me your text file. I think for Windows user, easily export it. For Mac users, you can copy and paste your text document. Any questions? So next week I start. Okay, there's two things. I know we ran out of time, but first next week we start Power BI, but it's optional because some of you has Mac, and I don't want you guys lose credit for that. For Windows users, is optional too because I cannot discriminate between Mac users and Windows users. But it's better to learn it and also take some LinkedIn course certificate and put it in your resume. The way that I teach you Power BI is similar. It's not look like Tableau. I give you some challenges, and we learn by doing those challenges, like how you learn operation research, this kind of thing. So each class I give you a problem similar to the problems that you did through Excel and Lingo, you do over Power BI. And also you have one more assignment for Efrat. So he would be, I think, October 22nd. I checked it, but almost one of the last weeks. Not the last week, 1 week before that. He comes here and check your assignment. So I think he asked you to do presentation thing. So he comes and gives comments for your presentation. If you cannot be in the class or you don't want to present, just submit your presentation. So submit a YouTube video or any video file. So I give it to Efrat and he checks later. But thank you very much and have a good rest of your evening.
Thank you.
Thank you.